Today we're going to do chapter 10, section 6, and it's called Trigonometric Functions. Now if you remember, we talked about functions, I want to say it was like our first or second chapter. It was a really long time ago. And what was a function? It was just when one variable depended on another variable, right? The way they defined it here is a function in mathematics performs a mathematical job, okay? So it is a set of ordered pairs. It just means that you're using one variable to find out your other variable. And then remember, for a function we have that test where you do the vertical line test. So every first element or every x is only going to have one y value, because otherwise when you do the vertical line test you don't get a function. And trigonometry, what have we been talking about? Triangles, right? So trigonometric functions are just all the things we've been talking about in triangles. Sine, cosine, and tangent are the ones we're going to start with. It's their function. So what does that mean? If you were to plot the sine, cosine, and tangent of every possible angle, what would those lines look like, right? So sine function. That just means that the sine of x equals y. Sorry, f of x equals sine of x. And remember, f of x is just a fancy way of writing y. So what is the cosine function? The exact same thing except for cosine. And again, remember, that's just another fancy way of writing y. And then what's our last one? Tangent. So f of x is the tangent, of x. Okay? So if you were to plot it in your calculator, which I'm actually going to have you do for a lot of these because I'm not going to draw them up on the board, you'll just say y equals tangent of x. And you'll get a graph, because every value of x is going to have a value for the tangent, right? So in the examples, that's what they do. I am not going to go in and graph all the examples, but I'm going to show you kind of what they look like so that you learn how to recognize them. Remember when we did x squared quadratic functions, we learned how to recognize what those graphs look like, and if it was cubed, what it looked like. It's kind of the same thing. You're just going to learn to recognize them. You'll be able to graph them, but if you have a quick multiple choice like on an SAT, you'll say, oh, that's what the sine function looks like. That's what the cosine function looks like, right? Now, all of these you're going to do in radians, which means that when you do if you're doing a little graph, you want to put pi or pi over 2 or 2 pi. So you want to make it as multiples of pi because all your radians are going to be multiples of pi, right? So what does example 1 say? It says graph f of x equals sine of x. So this one. Because remember, in your calculator, you're going to plug in, I believe you plug in y, or if you plug in f of x, plug that in. Plug in whatever your calculator says. And it says x is all real numbers, and then it gives you a range. So you want to plug it in for 0, less than or equal to x, less than or equal to 2 pi. Okay? Now, I'm not sure if you can enter ranges in your calculator, but if not, you can just, you can enter max and minimums, I think. If you can't, graph the function on your calculator, but only look at that area, the area between 0 and 2 pi for x. So I am going to do a very rough draft of this. Okay, and again, it's radians. So you want everything to kind of be graphed. This is always going to be 0, right? So that's going to be our smallest value for x. Let's just make this every other one be pi. So that's pi over 2, pi, 1.5 pi, 2 pi, so on and so forth, right? Make the same here. And of course, your sine and cosines aren't going to be multiples of pi, but they're still going to be huge decimals, so you might as well do this. Negative pi, negative 2 pi, negative pi, negative 2 pi, right? And you guys are going to do this on your calculator, so I'm not going to do the little number table which they have there. You can plug all the numbers in and get a number table, and then honestly you can just plug the whole function into your calculator and see what the graph looks like, right? So here's what it looks like. Your sine function is going to go through here and here and here. So it's going to cross your x-axis at 0, at pi, at 2 pi, at 3 pi. We're not going to go past 2 pi because they're telling us not to, okay? And it's going to make something that looks like that. Oh, and then it goes to 1. Let's say it's somewhere over here. Okay? that's what it's gonna look like. Your peaks here are gonna be at 1 and -1. And your points where you cross the x-axis are gonna be at multiples of x. All of your sine functions are gonna look like that. If you look at example 2, graph f of x equals sine of x again, except now they're saying you go from -4 pi right? The function is the same. Let's see, I'll draw it right there, let's say that's 3 pi. And then here it's gonna go like this. Okay, so it's gonna continue that wave. It's always gonna have, and we'll talk about this later, same frequency, same amplitude within the graph. So it's just this pattern repeating over and over and over again. The important thing to remember is you always pass 0, 0, and then you always cross. So that's gonna be pi 0, 2 pi 0, so on and so forth. And then up here, your peaks, your crests, if you've already done physics, are gonna be at 1. Let's call them peaks, which is a simpler name. At y equals 1 and y equals -1, okay? The values for x are gonna be pi over 2, 3 pi over 2, 5 pi over 2, -pi over 2. So it just follows a pattern. And again, I'm not gonna graph them on there because I'm not gonna have an accurate graph, but you can see how that looks for example 1 and example 2. Now example 3, you are graphing, I believe it says the cosine? Yes, you wanna graph the cosine of x. And you're gonna use this range right here, it says. When x is greater than or equal to 0, but less than or equal to 2 pi. Now, in this case, the shape is gonna be really similar. Except, let's see. Okay, you are gonna cross your axis here. Instead of being at 0, 0 like we were before, it's gonna be at y equals 0, but x equals 1. Let's say that's somewhere over here. Now in the graph in the book, they made the peak, the y value, they numbered it by 1s, and they valued this one by pi. I'm gonna do that right now to make this a little bit easier. But of course, then it's not really the scale, right? But the important thing is this one starts, call it the origin maybe, at 1, 0, okay? Now your little waves look exactly the same. So if you cut out the waves from the sine function, you could just shift them over so that your starting point is right here at 1, 0, and then you could have the exact same graph, okay? Now, here we're gonna cross at pi over 2, 3 pi over 2, 5 pi over 2, -pi over 2. Right, this is pi, this is 2 pi. So basically at half pi, at 1.5 pi, at 2.5 pi, and so on and so forth. You're gonna cross the axis. And then again, remember that you're gonna go down to 0 here. To 1. Not a terrible job here, but. That's kind of how it's gonna look, right? So the curve, your little wave, looks exactly like your other one, except your other one, remember, you could either say this point or this point was right here. So you either shift it to the right or shift it to the left by pi over 2. But it's the same graph. I'm not gonna pick all the points and plot them because I'm doing it on a whiteboard. You guys graph it on your calculator and look at the difference. Okay, so they're exactly the same except you shift it. Now, the graph for a tangent does not look like this at all. Okay, so we're gonna look at example 4, where they want us to graph tangent of x, which is this one, And we want our x values to be between 0 and 2 pi, okay? So you gotta flip the page over. On page 425 at the very top, it shows you what it looks like. I'm gonna go ahead and do it by numbers up here and by pi over here. So that's pi, 2 pi, and we don't really have to go further, but just for practice, I'm gonna do that. Now these are gonna be 1, 2, 3, 4, 2, 4. Negative 4, okay? So what is our graph gonna look like for that? Now, look at page 426 at the very top. You're gonna see that at pi over 2 and at 3 pi over 2, there are asymptotes. Remember what asymptotes are? They are a line that your graph is constantly approaching, but never actually gets to. Okay, so there's going to be asymptotes there. Then your line that I guess is kind of in the middle is going to cross at pi. So at x equals pi and y equals 0 is kind of the center of your line, and it looks like this. And again, that's a terrible drawing. On your graphing calculator you'll see. So if I just draw it between 0 and 2 pi, this is what it's going to look, well, not quite. It's kind of going to look like this, right? Now, for the tangent line, what happens is this keeps repeating itself, just like the sine and the cosine one do, right? So at 2 pi, you cross the axis again, and you have another asymptote right here. And your line looks, I'm going to try to make it exactly the same, but it's a carbon copy. So you take this graph, has asymptotes at pi over 2 and 3 pi over 2, crosses the x-axis at pi, and it has kind of that shape. Well, if you shift over to 2 pi, it happens again. If you shift over to 4 pi, it'll keep happening, right? Over here, same thing. Our asymptote is going to be at negative pi over 2. Now we're going to go through at 0, 0, because 0 pi is 0. And it's going to look the same. Okay? And it just keeps on repeating. So sine, cosine, and tangent are all repeating functions, because the same pattern just keeps repeating itself. It just shifts. Now, if you had some multiples, so if you put f of x equals 2 cosine of x, or 2 tangent of x, remember it's going to change the width of it, but your patterns are still going to look the same. Graph these on your calculator because it's a pain to figure out all the numbers, and you guys all have graphing calculators. Kind of look at these to get an idea, but you can also look at the ones in your book. Okay? Now, just mention the asymptotes for the function of tangent. Now, the other thing that is different, these, as I just said, all repeat, so all of these functions are periodic, and this term will come up more in trigonometry. It'll come up if you ever take calculus or pre-cal, and it'll come up in physics. Periodic just means kind of what you think about that it means in English, right? It happens every so often, so the pattern keeps repeating. It has a period that repeats over and over. The other thing that you see in these functions, the sine and the cosine, are what's called continuous. What does continuous mean? Basically, it's cursive. You can write the whole function without ever taking your pencil off the paper. The tangent one is a function, because if you do the vertical line test, you'll pass it. It is periodic because you keep repeating, but it is discontinuous, right? I make this line, get off the paper. Make this line, get off the paper. Make this line, okay? So, periodic, all of them, they keep repeating. Continuous, sine and cosine are continuous functions. Tangent is a discontinuous function, okay? So, you guys are going to do basically all of part A of the exercises. You're sketching graphs, do them on your calculator, and then kind of sketch a version on it on square paper. And for problems 4 to 8, where it says make a table and graph each function, find me a couple of values, but use your calculator for the most part, okay? So find a couple of values, maybe find pi, sine of pi over 2, a couple numbers like that. And then 9 through 11 are give the domain, and 12 through 14 are give the range. Remember, talked about this a long time ago. The domain is all your x's. So what possible x values can you have? In this case, for example, it's all real numbers, right? Unless they give you something like that. Except you cannot have x equals pi over 2, 3 pi over 2, 5 pi over 2, right? So you'd have to eliminate those. The range is all y's. Now in the tangent ones, it can pretty much be any y's, right? But remember, the cosine and sines, they go like this. So there's a maximum and a minimum y. So your range is going to be between those numbers. Remember to use the equal to or not the equal to underneath the greater than sign and the less than sign, depending on whether you're including that number or not. So for asymptotes, you are not including them. But for sines and cosines, you are including the peak because that's actually one of your values. Okay? So it should be pretty straightforward. Again, ask me questions if you have them at the Zoom, but 1 through 14, and for the ones where it says make a table, just pick a few numbers. Mostly do the graphing on your calculator, okay? That's it.